Alright, we got a new week here. Before we get into it, just remember my new video, my tutoring forum in the description. Alright, let's get into it now. For the topics, we got this stuff. Uh, Numerical methods are incredibly boring and also pretty easy. Same with this like random lesson we got here. Um, Everyone, good luck on getting your tracking test 5 back. Hopefully you all did well. But let's get straight into the assignment since the content this week is not interesting whatsoever. So to start, we are going to have this modulus question. So because it's plus a, we obviously need to show the gradient being steep and also that it's being shifted to the left because it's plus a in the modulus. Yeah, and then and then we also have to draw 1 over x. And then for part C, we just say they only intersect one time, and then solving, you just for solving it, you just have to set them equal to each other because you know it's the positive part of the graph, so you do the positive one, and you solve. And this was the form that they wanted in the answers, so it's all good. For part 2, this is just, well, you say that you know the d is 16 because it's the y-intercept, and then you just say this cubic is just going to be x plus 4, x minus 4, x minus 2, because those are the roots. And then you can just expand that. But the thing is, when you expand it, it's going to be, this value is going to be 32, and you know that d is 16, so you have to scale it down by 2. Yeah, and then that'll be your answer. Those are all your values, so half, -1, -8, and 16. Next, for R alpha, I have like a method that I use for R alpha, so I don't have to do all like the expanding, but I can explain it if anyone wants to know. You can put it in the comments, and I'll make like a short about it or something. Same thing. So R alpha shouldn't be too hard, even if you're doing it in the normal way. Then for this question, is you have to do another R alpha, and then you just have to say that the maximum value of that is just going to be when this is 1. There's supposed to be a root on that. I don't know why there isn't. So when sine of theta minus 75.964 is 1, which is the greatest value of it, so that's just going to become the coefficient, which is root 5.772. The value of theta where it occurs, it's just when sine of the thing equals 1, so you solve. And then for part D, the minimum is just going to be when this sine is -1. Or no, sorry, it's going to be when the sine is 1, because you're taking away, sorry. So you're going to get this eventually. And then part E, find the man value of t, where you have to set the r sine, but this theta turns into 360t over 365, but you set that in r alpha form, this bit here, equal to 1, because the minimum is actually going to be when it equals 1, because you're taking it away anyway. So if it equals -1, it's going to add because there's 2 negatives. So you set it equal to 1 for part E, and then solve. All right, we got some integrals here. So just remember your plus C's. So this is all reverse chain. Part what A, B is just reverse chain rule, like normal like numerical adjustments. Part C is a result that's honestly easier to just remember because it's just ln sec or negative ln of cos. This is just a kind of similar thing. This is another reverse chain. These are all just reverse chain rule integrals in different forms. So I mean, for this one you have to turn it. Actually, no. For this one you have to turn into double angles. So these two you need to turn into double angles, and then this one you need to use sec squared -1 for that one. This last one. All right. Next we have a parametric question. So we're going to differentiate. Finding the highest point on the bridge, well, that's just when the gradient is 0, which means that you can just multiply out by the denominator, you get sine t equals 0, and because this is the domain of t from pi over 2 to 3 pi over 2, t is going to be pi and not 0. And then the width is, you need to find the height as well, so you need to substitute that into the y equation, and then that's your height. For part B, you're finding from O to X, or from O to this where it says X here. So just these 2 points, and the way you do that is you just find the 2 points where t intersects the x-axis, and then you can put that into the x equation. Sorry, when x is So x should be 0 and then 80 here, yeah. And then that's your answer because it goes from 0 to 80, so it's 80 meters. Or it's 8 because 1 unit in the design is 10 meters in real life. Next question. This is just some easy implicit stuff. So this is a result that a lot of people forget. The a to the x is just a to the x ln a. Then this y squared is 2y dx, and then, or 2y dy over dx, and then this you have to use product rule, which always remember to use product rule when you have x, y multiplied together, or any two things multiplied together, like two different functions. And then when it has this coordinate, so you just substitute the values in and then solve. Yeah, inverse trig is actually quite a difficult topic, to be honest. Like it can get quite hard, but when you like kind of figure it out, it gets a little bit easier. So you set arc cos to y here, and then you can say x equals cos y, and then you can rearrange this to say sine y equals that, because if you were to like square this equation and then multiply it by -1 and then add 1 and then square root it, it would be root 1 minus x squared equals root 1 minus cos squared y, which is just sine y. And then tan y is just sine over cos, so just x over root 1 minus x squared. And then the only reason I knew this part B is because it came up in tracking test 5, and I kind of just had to figure it out in the exam. So for this domain here, if you graph arc cos and then arc tan of that, it's going to be the same from 0 to 1, but they're going to be flipped from -1 to 0. So you just say that so the thing you add here is going to be just pi, because or it's not even that it's flipped, it's just that the domain of cos is that the domain of arc cos is 0 to pi. The domain of this function is -pi to 0. So if you want to just copy it over, you just have to add pi when it's negative. So these are only the ranges when x is from -1 to 0. When x is from 0 to 1, they're both the exact same. But when it's -1 to 0, this becomes the range of both the functions, which means you just have to add pi to be able to copy the function over. All right, next question. We have this question on parametrics again. Differentiate, so dy dt over dx dt. Then finding tangents, well, yeah, it's not very interesting at all. You just substitute the t value in and then do your little equation of line and then rearrange, and you eventually get there. And then part C, so it's just a very complicated way of saying find the Cartesian equation and state the domain. So you can just say that so cos 2t is 1 minus 2 sine squared t, and 2 sine squared t is just y squared over 2. So you can substitute y squared over 2 in there, and then you can just find the domain from just putting in your calculator, really. Or you can substitute values in, whatever. Oh, your range, sorry, not your domain. Right. Oh yeah, this question is in the textbook, actually. They just took this from the textbook. So to find these points of intersection, you set them equal to each other and solve for x. It's pretty easy stuff. And then the y value, you know the y value is going to be the same, so you substitute it into one of them, and that's going to be the same. Now finding R1, it's remember from like year 1 integration, it's always upper curve minus lower curve. I wrote minus lower curve plus upper curve here, which is kind of confusing, and there should be a dx on the end as well. But so you do upper curve minus lower curve. It tells you which curve's which here, so that this one down here is upper curve, and then this one is the lower curve, because we're looking at only R1. And then you can integrate, not a very difficult integral at all. And then, I also use this rule where when you have an even function, which cos is an even function, you can, when you have from a to -a, you can just turn it into 2a to 0. If you just look at the graph here, you can see that this area is just 2 times the area from 0 to b. But anyway, it just helps you sum in the limits. Then you get this, and you get your answer of 4 root 3 minus 4 pi over 3. And then finding R2, you just do the same thing, but it's different limits. So the limit, because we're using the limits from the intersection points that we got earlier, we use this limit and we do the other curve minus the other curve this time. And we switch around the directions of the curves that we minus, because now this one is now the upper curve, this one is now the lower curve. and then again, not too hard of an integral. Sub your limits in, you get that, and then you like set them like ratio to each other, and then rearrange a little bit until you get the ratio that they're asking for. All right, this question, I think, or half of this question came up in the last assignment. So the coefficient of, or no, the term independent of x is just going to be the term where it's x to the 6 over x to the 6, also x cubed squared, and then over x squared cubed. And there's, if you think about all the other terms, there's not going to be any other term that's independent of x. So it's just this one. You set it equal to 80. You can do 10 choose 2 if, oh no, sorry, you can do 5 choose 2 if you want, but I just remember that it's 10 from like further maths, Pascal's triangle, whatever. And then you rearrange, you get your a values. You know the x's are going to, I don't even know why I wrote the x's, to be honest. But yeah, you get a is -2. Now this question, again, same as last assignment. For some reason, the reason why this is confusing is because this term doesn't include the k, this term does include the k. So you know that nk is 40 because the first term is just going to be nk times 1 to the power of n minus 1, but that's just going to stay as 1. And then it's just going to be n choose 2 is going to be all of this term here because it's all, the k squared is already here, the 1's just cancel, and then you have the x squared. So 120 is just going to be n choose 2, which is n minus 1 over 2. From that, you kind of have to use your knowledge from infinite binomial expansion that n choose 2 is n minus 1 over 2. Because that's where if you have done infinite binomial expansion, which you should have by now, that is what the n minus 1, n minus 2 over like 3 factorial or whatever, that's just n choose 3. That's why it's there, because it just replaces the choose function. So yeah, then you can solve this equation here for n, and then k is good. N is a positive integer, so this is just going to be 16, and then you can sub it in here to get k. Find the coefficient of x squared here. Well, this is actually a bit annoying. Wait, did I? Oh my god, don't tell me I did the thing again where I... Alright, well, this is our daily or weekly I didn't do the question part of the assignment. Yeah, I mean, this wouldn't even be hard again. You just find all the terms where they will multiply out to make x squared. That's the answer. I don't know what I'm doing. So now solving this is just, I don't even know what they were thinking with this question. This is easy. T squared of x is just t of x, so it's a composite function. So it's 5 minus 2, 5 minus 2x. And then you can square it, and then you solve, blah, blah, blah. You get your answer. This question, dy by dx, so dy dt over dx dt. Then you set t to a negative third, because you can figure that out from solving it. So if you, the x or the y equation, you can figure out t is. Then substitute your t value in, get m is 3, and then you just get your line. Part B for Cartesian equation, so you can solve, what did I do here? Oh, so I found t in terms, so this is what you had to do in tracking test 5 on the parametric question on paper 1. You had to, so you divide to get it in terms of t, and then you substitute that t into the other equation. So I got x minus 5 over negative 3 is t, and then I substitute that into this equation, and the fraction flips because it's 1 over, and then you can multiply the x minus 5 out and you get the answer. Alright, more integration. So I think they wanted you to use substitutions for some of these, but you didn't have to. So for this first one, it's pretty easy, just normal stuff. The second one, they use u to try and confuse you. It's the same thing. It's just going to be another standard result. This one, I guess you could have used u sub for this one, because I think that's the point of this question. They wanted you to use u sub. That's supposed to be a 7. And then this one, I think they definitely wanted you to use u sub, but you can just tell that when you redifferentiate this, it's just the 2's going to go away. When you have like a constant, usually you with like a ln, or in most integrals, you can kind of just ignore it, because when you redifferentiate it, it's going to go away. If you just try and integrate something, like just leaving the constant there, and then you redifferentiate it and it's fine, then it's probably right. And then this one's a partial fractions. This is a nice cover-up method, partial fraction, that you can do. kind of in your head. Oh my god, kind of in your head. And then you just do the lunds, and then that's the answer. This is another. Well, this is just they like doing this every like 3 assignments. They love including one of these questions just to remind you what it is. It's just the integral. So then you just do the integral. It's really not that complicated. All right, this last question was a bit annoying. So this triangle here, you have this. You can find BC by doing Pythagoras, and then you can, because it does tell you that there is that this is an arc, but you can figure out that DB or BD is an arc because this is 5 and this is 5, so they're both radii, and then so you just have to create like a careful diagram, and then you have to find this area. And how I found the area? I found the area of the triangle, and then subtracted the area of the sector, half r squared theta, and then you get the answer. All right, my voice is beginning to go, which is not good considering we're going to the applied section, but we should be fine. So, this question, exponential stuff, yeah, is really not that hard. So another hidden quadratic. Whenever you see something solving an equation with something to the 2x and something to the x, that's always going to be a hidden quadratic. As always with log questions, I did a lot of skips here. So part B, I bumped the 2 up here and then took away and then turned 2 into log base 3 of 9. This question was annoying. They wanted the answers in terms of lunds, which you could do with the change of base law. If you decided to do log base 2 of or log base 3, you could have used the change of base law to change it, but I just used the lunds because I remember last time they were asked you to use lunds in the answer for some reason. It's not terrible, I did, to be honest. And then this one was actually a little bit more interesting. So if you lund both sides, it would be ln x to the power of ln x, which is just ln x, which is ln x squared, and then you can square root it to get ln x equals, what is this? Oh, plus or minus ln 2, and the answer is going to be x e to the plus 1, because ln x equals plus or minus root of ln 2. It's not ln of root 2, it's the root of all ln 2. And that's why in the answer e to the plus or minus ln 2, you can't cancel the e and the ln in any way, I don't think, because the ln's in the square root. Alright, so now we're starting with moments questions. These are really annoying, or just any applied. I mean, mechanics, honestly, it's not bad, but when you get it in the assignments, it's just annoying because it's just so much work. So here you have your little rest, you have your little distances, and then you resolve upwards. So remember, when you're doing horizontal moments, or any moments really, you can resolve up, resolve sideways, and then also do your moments. They're the 3 things you can do to get equations that you can use. So here I resolved upwards and then took moments at the center. I don't know why I wrote M5G, so just M at the center. And you get that, and then you can substitute values in and then get the answer. Part B, similar thing. Oh no, this question really didn't make much sense. I think it's just a bit weird to think about, really. Because if you think about it in terms of like how it would actually work in real life, the strings would keep it. But if you thought about it in terms of mechanics, the strings wouldn't provide any upwards force or any like clockwise or anti-clockwise force, because they're just pulling strictly horizontally. But you just have to assume that they're going to pull it upwards as well. So if you just take moment at both of the tension points, you get both of the tensions. If you just kind of think hard enough, you'll be able to get the answer here. Next question. So this is the 2 conditions for the binomial approximation of normal, or the other way around. So you set up your binomial here, put it in your calculator, and then set up your normal with the approximation. Remember to do the continuity correction with the normal, and then I meant to put y here, not x, and then you get your answer. This is just p if x is greater than q equals 0.2. I think I did, this is supposed to be y again, my bad. Next we have a hypothesis test. We have, so this is a correlation test, pretty easy stuff. You can already instantly see from this test that this is going to be a reject H0 because the PMCC is basically -1, so there definitely is correlation. You find your critical value. It's a damn, alright, I messed that up. It's a lower tail, so you're supposed to say that -0.975 is less than -0.5822, and then that's why you reject H0. and then you do a little closing statement that I forgot to do. I just kind of was lazy. Next, another test, again, do the same thing, critical value with the formula book, compare them, fail to reject. Oh, and then this question, all right, we did this in class, so I kind of do actually understand what I'm supposed to do here, but if anyone that didn't do this question in class, I feel bad. Jesus, I feel bad. So you have these values of, I'd ignore this diagram, it doesn't actually mean anything really. So you have these two values here, right? So p of x is less than, it's not supposed to be an equal sign. P of x, so you have this, what's the name, sample mean that you have here. You don't really know anything here. You're trying to find n, that's your kind of idea. You actually only need one of these things. I don't know why it says either way. You only need one of these probability statements. And so you find the inverse normal of these things here, these things here. But for some reason, this is the one thing I really didn't understand about the question. The fact that because because we're saying 95% certain either way, so it's going to be two-tailed. But basically, we're thinking about a two-tailed test here. So you have to split that 95% into this. So this does equal 0.05. But when you're doing the inverse normal, you have to do the inverse normal of half of the value, and then you get these two values. It's symmetrical, so it's going to be the same. And then the thing that this is the moment that you realize you got it right is when you put it into this coding equation. The mu and the minus mu will cancel because x is mu plus 15. So if it's going to be mu plus 15 minus mu, that's going to cancel, and then you're going to get this here. So this is the z equals x minus mu of a standard deviation, because our standard deviation is just going to be this rooted. And then you can solve that for n, because your mu's are going to cancel. Next question. Oh, this is just critical regions. Just put it in your calculator. Right, we're almost done. So we have this sledge here. This is really easy. I mean, this is just some normal Newtonian mechanics stuff. So find the normal reaction, blah, blah, blah. So it's r plus t cos sine 20. And then finding acceleration, just resolve. And this question. So you have to find a new acceleration from because the tension's gone now. So you have to do so the only thing that's so I did another F equals MA thing. So the new R is 30G, just 30G because there's no tension. And you need that new R because so if we do F net equals MA, F net is literally just minus 0.2 R equals 30A because the mass is 30. And then you find your new A value. You know that the initial is 12. You know that it's gonna rest because it says to rest. And then you know the acceleration now, so you can do that and get your distance. This was absolute hell. Part B didn't make any sense. The points didn't. The points were like B and C. Nothing really made much sense in the answers. It was kind of just gibberish compared to what the question actually said. So I wasn't even sure if it was right. So I kind of just skipped that question. But for part A, this is definitely the longest part. You have to find the coefficient of friction here. So whenever you're doing ladder questions, always resolve up. You get this. Resolve sideways. You get this. Usually these will be the equations you get. It'll be one resultant force equals some amount of mg, because there's a load here as well. And then when you resolve horizontally, it will probably be one. It will probably be a frictional force equals the other reaction force. And then now we're taking moments, so you're gonna have to do a lot of things here. So because the thing is, you have to turn all of these into perpendicular or parallel to the ladder. And then, we're talking about perpendicular here. So what we're going to do, take moments at A here. And then, so we have, this is A away. This is 1.5 A away. This is 3 A away. And we can resolve. So this is going to be RB cos 30. This is going to be MG cos 60. This is going to be 2MG cos 60. And then you can factorize cos 60 out, divide through by your A's, turn MG into RA over 3. And then you can turn RB into just mu RA. Because what you could do here, you could turn the MG into whatever, and then you can find RA in terms of RB and then substitute. But what I like doing in these questions is you just substitute all of your equations. You substitute all of this into here, so that when you solve this, it will just give you the final answer. Because I've turned all of the MGs and I've turned the M's and the RBs into all RAs and mu's. So now we can cancel the RAs and get mu, which is going to be our answer. Yeah, I'm really struggling here. Oh god. What was I doing? Oh yeah. So now we got another, so part C. So again, I skip part B because of what I said earlier. Part C is going to be this thing here. It's just a lot of things. I don't really want to really explain it. We don't know where the center of mass is, so we're going to say this is distance, this is 3 minus distance, do your moments, and you get the distance, and that's your answer. Next, we have this thing here. So we do our distribution, find the problem, put it in your calculator, do the approximation, do the probability again, and then do another distribution. We're doing the classic like mu and sigma simultaneous equations thing. So you find the inverse normal of both of these, put them both in the coding relationship, and then solve them simultaneously, which I definitely didn't do on my calculator. If any teachers are watching. Next question. The rest of the thing gets a lot easier from here. So do interpolation. Boom. We haven't done this in a while actually. Just remember that the class width is 0.5, and then yeah, or you could do it like the long way if you want, but if you want to spend 10 minutes on a 2-mark question, then be my guest. Mean and standard deviation of the coded data, or mean and standard deviation, you use this data here. Oh god, you use this data here and 120, and then use the formula book. And then for the coded data, remember that the mean you just put into the equation, and then standard deviation is only the multiplier. Oh god, this question. So you had to do some speed time graph shenanigans here. So finding a speed when the parachute opens, where I use Suvat for all of this. You probably could use the graph, but I just prefer to use Suvat. So when the parachute opens, U is 0, A is G, T is 2, because we're saying that the parachute opens 2 seconds after she leaves. There's too many 2s and 4s in this question that just confuse me a lot. You find the velocity. Part C, minimum height is just going to be 2g, because that's how long it's going to take. Because U is 0, that's how long it's going to take for her to like open the parachute, and then you also have to use that to find. Oh, you have to also add on. So you have to add this distance onto this distance. So it's from here to here and then here to here. So add on those two, and then that's the distance. And then for part D, I did actually use the graph saying that this is 7, this is t. So this distance is 2 t minus 7. The area is 4 times t minus 7. And then you add everything, and you can find t. And then part E, air resistance. Cool. This is a nice question. Honestly, if I wasn't teaching single students how to do conditional probability, I would be done for. But thankfully I do. Just remember when you're doing conditional, so the givens, you just you do both of the. You don't really use the formula, because when you get stuff like this and this, the formula makes a lot less sense. You just think, all right, it's going to be both of them over just the second one. So it has to be. So that this is just P of D dash intersection C over P of C, which you think is just the formula, right? But it helps you when you look at the Venn diagram. You think, oh, if you just think about this one, D intersection C, so that's 1/12 over just C, so that's 1/6 plus 1/12, and then that's going to be your answer. But anyway, so when you have a probability question, honestly, before even reading the question, just or before even reading like this here, like what you're actually supposed to do, just look at what you have and just try and find all the information that you can. So here, I did I set out the equation for C given D, and then substitute P of D in to find C intersection D. So you can put that on the Venn diagram. You can put then now you can find this bit here, and then now you can use this as well. And then because I looked at the question and realised that this was just what this was asking, so I just put part A here. Then you do the exact same thing to find P in C intersection not in D. So then now you can put that there, and then you can do 1 minus all of that to get this probability. Now we have the Venn diagram, we can just do all the other ones quite easily. So we can just say that what I said earlier, so it's going to be both over just them two, and then we're just going to do the similar process for this. So if you want to use the formula in the formula book, you can. So this is going to be P of D dash intersection C over P of just C. And then similar thing for this one. Next question, vector mechanics, not interesting at all. Alright, relative velocity, I don't know why this is here. This is something that used to be in like further mechanics back when, like, in the old specification before, like, 2017 or whatever. But it's not on the specification. It's never come up. It never will come up. It might come up for, like, something like Part A. Part A is something that could come up. Maybe Part B. Definitely not Part C. I don't... Oh, this is... Yeah, this one I didn't really know what was going on. But, so, relative velocity just means that, like, let's say you're in a car and someone else is coming towards you. And, like, someone is coming behind you. Like, there's another car behind you that's moving. Let's say you're moving at 20 meters per second. The car behind you is moving at 30 meters per second. In relative to you, in the car that's at 20 meters per second, that other car is moving at 10 meters per second. That's what relative velocity is. So C relative to D is you're just gonna take them away from each other, basically. That's how you're gonna find it. You're basically just finding CD. You're basically treating these as position vectors and just finding CD. DC. Then, or whatever gives you this answer. And then so now we're finding S being the relative position vector, I think. Yeah, the position vector of C relative to D is S meters. So you're just going to take them away from each other. So you're just going to do RC minus RD. And then you're going to get the answer, like what I said earlier. So modulus S squared, well, that's just going to be the square root of this stuff all squared, so they can cancel out. And then you just solve this, because there's probably a way to think like, oh, the magnitude is going to be like where they're closest together, but I genuinely had no idea. I just solved and it was the right answer, so I did it. So yeah, I didn't have to understand it, because relative velocity is just something that isn't, like, I had a whole rabbit hole trying to find stuff that was related to relative velocity on the new spec. I cannot find a single thing. So just don't worry about it if you didn't understand this question. Next, this is easy. Just differentiate, solve, substitute, integrate, solve, substitute, or just integrate and solve, not even substitute. Right. Yeah, sorry, I didn't explain that very well, but it's just variable acceleration. I explained variable acceleration better in previous assignment videos, but my voice went like 10 minutes ago, so we're gonna have to wrap it up soon. Well, because the assignment's almost over. Anyway, last question. So this is kind of like a classic proof. So if you square both sides and then expand, take away, you can factorize it. Oh, this is supposed to be p minus q squared, actually, sorry. But anyway, so any number, even if it's negative squared, is always going to be greater than 0. And because because they're both positive numbers, they can't it can't be 0. The only case where this isn't true is when p minus q squared is 0, which it isn't, because they're both positive, and they're both separate positive integers, so that's going to be fine. Oh, actually, yeah, wait, what? So if it's this part B, because I thought this was p plus q for some reason, but this is actually p minus q all squared. So because we know that p doesn't equal q, that's why this works, because anything squared that isn't 0 is greater than 0. But by part B is going to be wrong because I messed that up. But so if they're both negative, what's going to happen? Oh yeah, because it would be if p was like, yeah, actually that doesn't make any sense. What? How is, if p minus q, sorry, I don't know how I've confused myself here. I mean, I was not in a great spot while I was at question 15 on this assignment after just starting from question 1, section A. But I think, just keep going until you find out. You can just set p minus q squared equals, just when p equals q, though, that's the thing. Yeah, I don't really understand this last part. But yeah, I don't even really know what's going on. But this part makes sense. I don't really know about this part. This should be like a 1-mark question anyway, and you could probably figure it out. Right. Anyway, yeah, thanks for watching. Sorry about my voice. I don't know what happened to it. It just randomly went after like question 5 of section A. But I'll see you next time. Goodbye.